On an average spring morning, a visitor rents a kayak at the eastern entrance of the Okefenokee Swamp, checks her permit, and paddles in. The water beneath her hull is black, not murky. Black. She assumes this is sediment. It is not sediment. It is 7,000 years of decomposing plant matter, and the ground beneath that water is not ground at all. It is floating. In the Okefenokee, that distinction is the difference between a paddling trip and a survival situation. Every year, roughly 600,000 people visit the Okefenokee National Wildlife Refuge, a 438,000-acre swamp straddling the Georgia-Florida border. Most experience it through the 2% of the refuge that has designated trails, boardwalks, or paddling routes. They see the alligators from a safe distance, photograph the herons, and return to their cars, having encountered what feels like a contained and managed wilderness experience. The other 98% of the Okefenokee, the part that has never been touched by a trail or a boardwalk or a human footprint, is out there doing what it has done for millennia, burning underground, shifting underfoot, and accumulating toxins that move silently through the food web toward everything that lives in or near it. The illusion of safety in the Okefenokee is different in character from the illusions that operate at the Grand Canyon or the Boundary Waters, but it functions by the same mechanism. Infrastructure signals control. The permit system, the ranger stations, the outfitters, the designated campsites on elevated wooden platforms. These things create the impression of a managed environment in which the most serious risks have already been identified and mitigated. They have not. The Okefenokee has defeated every attempt to manage, drain, log, mine, and suppress fire across it for more than a century. The permit system tells you where to paddle. It cannot change what the ground beneath the water is made of. The first illusion is that the Okefenokee is a swamp in the conventional sense, a wet, murky landscape with firm ground underneath. It is not. The Okefenokee sits in a shallow depression that was once part of the Atlantic Ocean, bounded on its eastern side by Trail Ridge, a fossilized barrier island formed 1.8 million years ago that acts as a natural dam, trapping rainwater in the basin. Over the 7,000 years since the last ice age, partially decomposed plant matter, peat, has been accumulating in that basin at a rate of roughly 1 inch every 50 years. In some places, the peat layer is 15 feet deep. Beneath it, there is no rock, no firm foundation, no substrate. There is water, and then there is the sandy remnant of a Pleistocene seafloor. Some of that peat has detached from the bottom entirely and now floats. These formations are called batteries, and they drift through the swamp like slow-moving islands. Full-grown cypress and black gum trees grow on them, rooted into mats of organic material that have no connection to solid ground. A pole pushed straight through one of these islands will disappear into the peat with no resistance and no bottom. Some batteries are stable enough to walk across. Others will collapse under the weight of a person. There is no reliable way to tell the difference from a canoe. A visitor who steps onto what appears to be solid ground finds the surface rippling outward like a waterbed. Stomp, and the entire island shakes. Press too hard, and the surface gives way into 15 feet of waterlogged, oxygen-depleted peat so dense it can close over a body without a trace. The Muskogee people who named this place called it the land of trembling earth. That was not a metaphor, it was a physical description of what the ground does. The second illusion is that the primary dangers in the Okefenokee are the ones that are visible. 15,000 alligators inhabit the swamp, according to the most recent U.S. Fish and Wildlife Service estimates. 5 species of venomous snake share the waterways with them. These are real hazards that require real awareness. They are also the hazards that every visitor is told about, that every guidebook addresses, and that the visual drama of the swamp naturally foregrounds. The dangers that are most likely to cause serious, long-term harm in the Okefenokee are the ones that are invisible. Underground fire that burns for months beneath apparently solid ground, and mercury contamination moving silently through the food web at concentrations that have been documented in the swamp's apex predators at 8 times the expected level. The third illusion is that a landscape this wild, this remote, and this resistant to human control is at least stable in its hostility, that its dangers are consistent and predictable even if they are severe. The Okefenokee is not stable. It is a dynamic, fire-dependent ecosystem that has been fundamentally altered by a century of human interference in ways that have made its most catastrophic events not less likely, but considerably more so. Start with the ground, because in the Okefenokee, the ground is the foundation of every other danger the swamp presents. As peat decomposes in the anaerobic conditions beneath the swamp's surface, it releases methane. Visitors paddling through the interior will sometimes see bubbles breaking the black water, methane rising from the peat below. In certain concentrations, that gas is flammable. The water bubbles with it. The ground floats on nothing. The surface a visitor walks on is, chemically and structurally, fuel. This is not a background condition that can be managed around. It is the physical nature of the swamp itself, and it is the reason that the Okefenokee's most catastrophic events are not floods or storms or animal encounters. They are fires. Underground fires, burning through material that has been accumulating since before the Egyptian pyramids were built, in a landscape that provides no mechanism for surface water to extinguish them. Peat fires are among the most dangerous and least understood fire events on the planet, and the Okefenokee is one of the most fire-prone peatlands in the Western Hemisphere. When drought lowers the water table and exposes the upper layers of peat to air, a single lightning strike can ignite material that has been building for thousands of years. The fire does not stay on the surface. It burrows downward into the peat, smoldering underground where no one can see it, spreading laterally through root systems and decomposition channels, burning at temperatures high enough to consume the very substrate the swamp is built on. These fires can burn for months, in some cases for years. A person can stand on the surface of the Okefenokee with no visible flame anywhere in sight, and 6 feet beneath their feet, the ground is on fire. The 2011 Honey Prairie Fire began with a single lightning strike on April 28th. It burned through 309,000 acres of the Okefenokee, roughly 75% of the entire refuge, and was not declared extinguished until April of 2012. Nearly a full year of continuous underground combustion. During that period, there was almost nothing firefighters could do. A fire break cannot be dug in a peat swamp because the peat itself is the fuel, extending downward in every direction. Surface water applied to the top layer simply sits there while the fire continues burning beneath it, invisible, until it erupts days or weeks later in a location no one predicted. The 2011 fire was not the largest. In 2007, a lightning strike near the center of the refuge ignited what became the Bugaboo Fire, which merged with a separate wildfire started when a tree fell on a power line near Waycross, Georgia. The combined fire consumed more than 600,000 acres, over 935 square miles, and remains the largest wildfire in the recorded history of both Georgia and Florida. The smoke was visible from space. Residents smelled it hundreds of miles away. Major fires in the Okefenokee have been documented in 1844, 1860, 1884, 1908, 1932, 1954, 1990, 2007, 2011, and 2017. That is not a random distribution. It is a cycle, roughly every 20 to 30 years, and human fire suppression has made each event in that cycle more severe rather than less. The mechanism behind this escalation is well understood and, in retrospect, predictable. The indigenous peoples who managed the Okefenokee for centuries, the Timucua, the Muskogee, the Seminole, used controlled burns to clear accumulated vegetation and interrupt fuel buildup. They worked with the swamp's fire cycle rather than against it. When those populations were forcibly removed in the 19th century and logging operations moved in, prescribed burning stopped. Without regular fire, hardwood trees expanded into areas that had historically been open wetland prairie. Understory growth accumulated. Peat dried in areas where regular burns had previously kept it moist. When drought came and lightning struck, as it always eventually does in northern Florida, there was decades of accumulated fuel available. The result was not a manageable burn. It was a mega fire that consumed everything the suppression strategy had been protecting, along with everything else within reach. A century of trying to prevent fire in a landscape that requires fire to remain ecologically functional produced exactly the conditions that made fire catastrophic when it finally arrived. But the fire danger in the Okefenokee is, at least, dramatic enough to register. It produces visible smoke and measurable acreage and named events with dates attached to them. The swamp's other invisible hazard operates with none of that visibility, and its consequences are distributed across the food web in ways that make them almost impossible to trace back to their source. In 2025, researchers from the University of Georgia published findings from a study of mercury contamination in American alligators across 3 locations in the southeast: the Okefenokee Swamp, Jekyll Island in Georgia, and the Yawkey Wildlife Center in South Carolina. Alligators in the Okefenokee carried mercury levels up to 8 times higher than alligators living on the coast. Mercury is a neurotoxin that accumulates as it moves up the food chain through a process called biomagnification. A dragonfly larva absorbs a trace amount from the water. A frog eats the larva. A fish eats the frog. A bird eats the fish. An alligator eats the bird. At each transfer, the concentration increases. By the time it reaches an apex predator that has been accumulating for decades at the top of the Okefenokee's food web, the levels can be devastating. Neurological damage, reproductive failure, organ breakdown. What the researchers found in the hatchlings was more disturbing than the adult contamination levels. Newborn alligators, animals that had never eaten a single contaminated meal, were already carrying elevated mercury. The toxin was being transferred from mother to offspring through the egg yolk. The contamination is not just environmental, it is generational. It is embedded in the reproductive biology of the species that has lived longest and most deeply in this ecosystem. And the Okefenokee is not a closed system. Its waters form the headwaters of the Suwannee River, which flows to the Gulf Coast of Florida, and the St. Mary's River, which empties into the Atlantic Ocean. Both are active fishing destinations. If the apex predators at the headwaters are carrying 8 times the expected mercury load, The question of what that contamination looks like in fish being caught and consumed 100 miles downstream is one that researchers have not yet fully answered. Part of what makes the Okefenokee such an efficient accumulator of contamination is its hydrology. Coastal marshes are flushed twice daily by tides, which disperses contaminants before they can concentrate. The Okefenokee does not flush. Water moves through it slowly, sometimes barely at all. Mercury settles into the sediment, is taken up by microorganisms, and enters the food web with nowhere to go but upward through the chain. The swamp functions as a collection basin for pollution it did not generate. Coal combustion, industrial runoff, and atmospheric deposition from sources that may be hundreds of miles distant, and concentrates it with the same efficiency that has made it one of the most productive wildlife habitats in North America. And then, yes, there are the animals, which are real hazards and which are genuinely present in numbers that most visitors do not fully appreciate until they are already inside the swamp. 15,000 alligators inhabit the Okefenokee. They are not passive background features. They are the ecosystem engineers of the swamp. They dig the ponds that provide refuge for fish during drought. They move the sediment that keeps the soil cycling, and a large adult can exceed 12 feet and close its jaws with enough force to shatter bone. During mating season, April through June, which overlaps almost exactly with the peak visitor season, they become territorial. A female guarding a nest will hold her position, hiss, and is not bluffing. The alligators share the waterways with 5 species of venomous snake, including the eastern diamondback rattlesnake, the largest venomous snake in North America, and the Florida cottonmouth, which holds its ground rather than retreating and is the species most commonly encountered in the narrow paddling channels, where vegetation closes in and there is not always room to maneuver. Historical records show that among 400 cypress cutters who worked in this swamp during the early 20th century, not a single snakebite was reported. Those men knew the swamp. They read its behavioral cues. Most visitors arriving with rental kayaks do not. The deeper issue with the Okefenokee's animal hazards is not their presence, but the isolation in which an encounter would occur. Cell service does not exist in most of the refuge. The nearest town for many interior paddling routes is Folkestone, Georgia, a small community at the swamp's eastern edge. If something goes wrong on an overnight paddling trip deep in the wilderness, a capsize in alligator territory, a step through a battery into the Peat, a cottonmouth that holds its ground in a channel too narrow to reverse, the realistic response window is measured in hours of paddling back to a ranger station, not minutes of waiting for rescue. The swamp does not pause because a visitor is in trouble. It continues doing what it has always done. The Okefenokee's resistance to human control is not a recent discovery. It is the accumulated lesson of every attempt made to bend this landscape to human purposes over the past 2 centuries, and those attempts have been numerous, well-funded, and unanimous in their failure. In the 1890s, the Suwannee Canal Company attempted to drain the entire swamp and connect the Suwannee and St. Mary's rivers for commercial navigation. They dug a canal 12 miles long and spent years and considerable capital trying to move water out of a basin that had been collecting it for millennia. The company went bankrupt. The swamp would not drain. From 1909 to 1927, the Hebard Lumber Company logged thousands of ancient cypress trees, some of them 900 years old, and built a logging town of 600 people on Billy's Island, deep in the interior. When the commercially valuable timber was gone, the operation was abandoned. The swamp reclaimed the island. The rails rusted. The buildings collapsed. The equipment is still there, slowly being absorbed by the same landscape it tried to extract value from. In 1997, DuPont proposed a 50-year titanium mining operation along Trail Ridge, the same fossilized barrier island that keeps the Okefenokee's water from draining east. Public opposition ended the project, and DuPont eventually donated 16,000 acres to conservation. In 2018, Twin Pines Minerals proposed mining Trail Ridge again. The U.S. Fish and Wildlife Service warned that breaching Trail Ridge could lower the water table, expose peat at scale, and transform the Okefenokee from a carbon sink into what one ecologist described as a carbon bomb. The swamp stores an estimated 200 million metric tons of peat, equivalent to 415 million metric tons of carbon dioxide, more carbon than all of Georgia's forests combined. If that peat dries and ignites, the climate consequences would extend well beyond the swamp's borders. In June 2025, the Conservation Fund purchased all 7,700 acres of Twin Pines holdings for $60 million, ending that threat permanently. The swamp has been nominated for UNESCO World Heritage status, with a decision expected in Busan, South Korea, in 2026. Here is what ties all of this together and what makes the Okefenokee genuinely unusual among American wilderness destinations. The Grand Canyon announces its own danger. It is visually extreme, a mile-deep abyss that no visitor mistakes for a gentle landscape. The Okefenokee does not announce anything. It looks like a beautiful, still, wildlife-rich wetland. The black water reads as mysterious rather than as evidence of 7,000 years of accumulated organic decomposition. The floating islands look like solid ground. The mercury in the food web is invisible. The underground fire is invisible. The peat that can swallow a person without a trace looks, from a canoe, like the bed of a shallow lake. The swamp presents none of the visual cues that human threat detection evolved to notice, and it is dangerous in ways that require specific knowledge rather than instinctive recognition. The people who have understood the Okefenokee best are the ones who lived with it longest. The Muskogee called it the land of trembling earth and managed it with controlled burns for centuries. The cypress cutters of the early 20th century worked inside it for years without a snakebite because they learned to read it on its own terms. The swamp rewarded that understanding and punished the assumption that it could be controlled, drained, logged, mined, or suppressed into stability. Every institution that approached the Okefenokee as a problem to be solved discovered, at significant cost, that it was not that kind of problem. The Okefenokee is not trying to harm anyone who enters it. It is simply being what it has been for 7,000 years, a vast, fire-dependent, methane-producing, mercury-accumulating peatland ecosystem that operates according to physical and ecological laws that do not make exceptions for visitors, permit systems, or paddling itineraries. The ground still trembles, the fires still burn underground, the mercury still moves up the food chain, and every year, when the water drops and the peat dries and the lightning comes, the swamp does what it has always done. It doesn't care that you have a permit. It never did. Subscribe, because the wilderness doesn't warn you, and someone should.